I know it's kind of hard to see here, but what I want you to do is you see this red line, that's the margin line. Okay. What I want you to do is I want you to make like little points along where the red line and the lines of the paper intersect each other. Okay? So just draw some little dots here on every single one of these lines. Sure. All right, so I've drawn every single one of these points. I'll give everybody a second to catch up. And then what I want you to do when you're done is I want you to, somewhere in the middle, maybe like where that middle circle is for the hole punched, I want you to put a point somewhere above there. And it does not matter where. Now what we're going to do is we're going to take every single one of these points and we're going to fold our paper so this point matches onto this point. So watch. I'm going to, and it's kind of very faint, but I want to see where this point, and I'm going to fold my paper. And I'm going to do that with every single point. It doesn't matter. You're gonna just fold every single point. I might need to make mine a little bit darker. It's kind of hard to see, but.
Wait, what do you do?
You're gonna match up every point that's along that line with the middle dot. Okay. So watch. Okay. I'm on the fourth dot. I'm going to take that dot and fold the paper. And then the next dot, and I'm going to fold the paper.
Oh, okay, good.
Alright, and then you're going, but you know what I do? I just do this. I can just like slide it up, right? I don't really need to refold it. You can just slide it up. Does that make sense? Okay. Alright, so we're just going to keep folding. And we're going to just keep folding.
Are we doing it for every single one?
Yeah?
Oh.
Oh my goodness, that's torture.
It's a little bit. It makes me curious as to what we're doing this for.
So just start making like tiny lanes.
All right. All right, luckily, see, next period I don't have to do this. I can just show everybody when I'm finished. All right. All right, I'm going to start the other side. Actually, let's do this. Yeah, you got to do both sides.
Oh my.
Why? Because I said so.
So do we draw the dots on the other side too?
You should have had a dot on every single line, on both sides.
Oh no, I thought you meant the other side of the paper with the other
Yep,
margin.
yep, yes, sir.
Is this the one where it's like a graph and it has like the curved lines kind of looking?
I don't know. Maybe.
This would be a surprise.
I don't know.
Are you making fun of me? Because if you are, I wouldn't recommend that.
Yes, ma'am.
I think that's good enough. What did you do? Okay. I just
All right, and then what you want to do when you're finished is you kind of want to hold it up. Okay, so you want to hold it up, and what does that look like? It's a parabola.
I can't even see what I'm doing.
Why? Is that what somebody said?
Yeah.
All right, here's the why. Because what we're doing is, this is an activity. Well, let me ask you something. So what we've done is we've taken each point here and mapped it to that point. So what we've created is this parabola that is from the set of points equidistant from a point and a line. So think about it. I've taken, it's not a Drew. Are you folding? All right, Drew.
Yes.
It's okay.
Okay.
It is certainly okay. The idea is though, okay, what's the idea of the activity? The idea of the activity is to show you that we are actually going to be talking about a parabola that's formed by a definition, not from a quadratic equation.
Is this anything close?
What do you mean a definition?
Okay? Here's the definition. Okay? All right. So, okay. So, a parabola, guys, seriously, a parabola is going to be the set of all points, equidistant from a point, which is called the focus, and a line, which is called the directrix. Okay, I'm not collecting your little folding activity. It was more for the idea of why we're using. Now, so here's what happened. We now are going to be studying parabolas that not only open up and down, but we're going to be studying parabolas that now open right or left. Okay? So, there are other characteristics. So, we're going to be basing our parabolas now on the focus and then the directrix. So let me hand out your notes for today. And I have some sample problems. Guys, we really need to keep the talking to a minimum, please. Good job.
True.
All right, so here are the notes that I just handed out to you. Okay, So we're going to actually be studying two types of parabolas. The parabolas that open up and down, and the parabolas that open right or left. Today, we're only going to be talking about parabolas that open up and down. Now, what you should notice is this is very different than what the equation that we've been studying before. Because remember, the equation that we were dealing with last week and previously was based on a quadratic equation. We're not dealing with a quadratic equation. We're dealing with it from a definition standpoint of the distance. So, what you're going to notice is that this is going to open up or down. Okay? And the reason it opens up or down, when we get to that point where they're all mixed up and you have to determine, there's going to be a number in front of the y. Y is up or down, so that's how you know it would open up or down. Whatever number is with the variable. See here? This is going to be a number, and it's with the x, so x is right or left, so that's how you know it opens right or left. Okay? So, same idea with positive, negative. If this number is positive, it's going to open up. If this is negative, it's going to open down. Same idea that we had with the A with the quadratic equations. Okay, so here's how you're going to go through the steps of graphing. Okay, the first thing you're going to do is identify what 4p is, what h, and what k is. Notice that whatever is in the grouping symbol, you have to change the sign. Because it's supposed to be minus k. It's supposed to be minus h. Okay, you're going to graph the vertex, and then you're going to solve for p. So 4p is going to be a number. So this is all on your paper. And let me just kind of talk you through it, and then I've got some examples on the back that we're going to actually go through step by step. Okay, you're going to determine and graph the focus. And the focus is going to be located p units from the vertex. So back to my little graph, that the line where all the points are, the red line of the margin, that's your directrix. And this point that I graphed here is the focus. So the vertex, when I fold the paper, straight in half like that, right? This point here is the one that's going to be the vertex. It's the same distance from the line and from the point. They all are, but that's the shortest distance, right? So that's going to be my P. Okay, the directrix is a line, okay, and that line is going to be P units. So let's see here. You're going to identify the vertex, it's right here. P is going to be the distance from the vertex to the focus. Graph the focus. And the directrix is the other direction. And you draw the line. Okay? And these are just how you determine the equation of the directrix. And then we have what's called the focal width. Zach?
What would you use a directrix for?
Okay. Okay, remember what I said at the beginning of the period. We're graphing these based on a definition. And the definition is that it's the set of points that are equal distance from a point, the focus, and a line, the directrix. That's what the directrix is for. Because we are basing these strictly on a definition. Okay, so the focal width tells me how wide the parabola is through the focus. So that's how I get an additional point to be able to graph and sketch the parabola. Okay? And then the axis of symmetry, that's the same kind of thing that we talked about before. X equals the h coordinate, okay? So, and then there's just a little graph. This is a little bit different. You can see, somebody created these, and this says y-axis and that says x-axis, but on your paper I think I wrote it in there, right? That I called this the x-axis. I think I put it over here. But here's your diagram, okay? Here's my directrix, here's my vertex, and my focus. So it's the same distance from the focus, and the directrix are the same distance from the vertex. And then I'll show you, and then focal width would look like this. It's going to be how wide the parabola is through the focus. That will be my focal width. It's the absolute value because it's always positive, because hypothetically you can have something that's opening down and it would be negative. Alright, I will go very slowly, okay? I know this is new, so I will go very slowly. If you have a question, please let me know.
How come it's underlining directrix in red? Isn't that a word?
It's obviously not a word. Okay, so what's my vertex going to be, gentlemen? What's my vertex going to be? No?
1, 2.
Okay, 1, 2. So why is it 1, 2? Because this is x, this is y. They go together. So whatever number you see with the x is the x coordinate of the vertex, and whatever number you see with y, that's the y coordinate of the vertex. So my vertex is 1, 2. Okay. I also need to find the focus and the equation for the directrix. So in order to do that, I need to find out what P is. So this number right here is for P. So P is going to equal 2. Alright, so now I'm going to graph this. Alright, so I'm going to start by graphing my vertex, labeling that with a V. Any questions so far? Don't be shy.
How come the x and y axes aren't already drawn in on these graphs?
Because that way it gives you some leeway as to be able to fit it on the graph better. Right? Okay, so now, which way does this open? Excellent, it opens up. So therefore, my focus is located 2 units up from the vertex. The focus is located 2 units up. I call this graph as you go. You're graphing it to find where the focus is located, then you're going to tell me what point that is. Make sense? Okay, so 2 units up, here's the focus, and that's going to be 1, 4.
So that's when you use P, right?
That's when you use P. So this right here, this distance here is P. So now I'm going to go the other direction, P, to find the directrix. Well, the directrix is actually going to be the x-axis, correct? So, and it's a line. It's going to be y equals 0. Alright, the next thing I need is, even though it doesn't ask you for it in the directions, we want to say what the focal width is. And the focal width tells me how wide the parabola is through the focus. So 4P is my focal width. So it is 8. So this is 4P. Alright, so now what I'm going to do is I'm going to, that means the whole width of the parabola is 8. with the focus being in the middle of that width. So I'm going to start at the focus and I'm going to go half and half. So how many this way?
4.
And 1, 2, 3, 4 this way. And there's my vertex. And I missed that point, but that's how I graph it. And that's it.
That's it.
Christopher.
Where did we get the 4 across?
Okay.
Oh, okay, never mind.
That's okay. I'll show you. Okay? This right here is the focal width. So that whole thing has to be 8 with the focus being in the middle. Yes, X.
Okay, so, say the number before, or so the 8 is like a 4. Would that mean that the point, or the focal point in the director is like 1?
Yes.
Okay, and then would that make the focal width?
4. Yeah?
Okay, I got it.
Okay, let's look at number 2. Brendan.
What's the focal width 8?
Why is it 8? Because it matches this
Oh.
number here. So what would the focal width be on this problem?
12.
Alright. Okay, but let's start from the beginning. Do you need to adjust?
It's okay.
Okay. Alright, so the vertex, my friends, is going to be 2, -4. Which way does this open? Up. It opens up because that number is positive. Alright, now I need to find the focus. So in order to find the focus, I need to know what P is. So if this is supposed to, if 12 is supposed to be 4P, then P has to be 3. Alright, so I want 2. So here's what I might do. I have 2, -4, and then I have a focal width of 12. So I might need to adjust my graph and not put it straight in the middle, and it's going up 3. So let's see, I might do, let's see, 2, -4 would be down here. So I guess it's really not going to matter in this case. All right.
You don't have enough space.
So 2, 1, 2, 3, 4. Here's 2, -4. That's my vertex. I like everything to be labeled. B and F is fine. Okay, so 3 units is where I would locate. I use 3 units from the vertex is the focus and the directrix. The focus is located the same direction the graph opens from the vertex. So if the graph opens up, the focus is up from the vertex. Got it? Alright, so that means 1, 2, 3, here's my focus, and 1, 2, 3, here's my directrix. So my focus is located at 2, -1, and my directrix is the line y equals what? -7? Okay. Alright, my focal width is how much? 12. So since my focal width is 12, I divide that in half, 6, and then I do what? Go right and left 6 from the focus. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then there's my parabola. Bless you. Any questions so far? Everest?
So why do we need to find the directrix? Like, what is it doing?
Okay, again, these are no longer quadratic equations. These are a definition of a parabola, okay, so what this is saying is, do you see this point right here? This point is the same distance from this line and from that focus. So if I pick a point anywhere on this parabola, it's going to be the exact same distance from the line and the focus. So you see this point? That's the same distance. This point right here, this distance, and this distance would be identical. So we are using the definition of a parabola, not that it's a quadratic function. Yes?
Why are they so wide? Why are all the parabolas so far so wide?
Why are they wide? Because this is really, if you move that over, it would be like 1/12. That's why. All right, we have two more. And these won't be as wide because these numbers are not as big.
Zero for x.
Yes, very good. Okay, so someone said x is 0 for number 3. Yes, it is. There is not anything being squared. So here, for this one, my vertex is going to be 0, 3, and P is what? Okay, it's going to be 1. We keep it positive, but which way does this graph open?
Down.
Down. All right, so let's. So 0, 3, here's my vertex. 1 unit down is what? Excellent. The focus is 1 unit down, and 1 unit up is the directrix. So my focus, reading it from the graph, the focus is going to be located at 0, 2, and the directrix is the line y equals 4. And what's my focal? I'm sorry, that was too fast. You good? I just caught myself just kind of moving too fast.
So is our p and the focal width, but there's always just going to be a positive number?
Yes.
Okay.
Because we're talking about a distance, the negative is only going to tell you up or down, or down or left. Drew, you all right?
Yep.
Okay. So now I want to graph what? The focal width. So how wide is the focus? How wide is the parabola? 4 units. And I know that because of 4p, but I'm going to go how many in either side of the focus? 2. So 1, 2, 1, 2, and then there's my graph. All right, this next one requires a little bit more thinking. These are pretty simple. This one is a little more challenging because 4p is 1. Yes, Ben?
Wait, why wouldn't P be -1?
Because we're talking about a distance.
Oh, yeah.
The negative is just telling you down.
Okay.
Okay? All right, so let's look at number 4. So my vertex is where?
-1.
-1, -2. Which way does this open? Up. And P is equal to? No? No? Okay, what's 4P? 4P is what? 1. So P is 1/4. All right. So, -1, -2, here's my vertex. Which way do I move to find the focus? Up. So, I'm going 1/4 up. What point is that?
-1,
-1, 1 3/4, right? Because I'm 1/4 away from -2. And then my directrix, I probably didn't need to make it that long. And my directrix now is 1/4 down. So that equation is y is equal to -2 1/4. How wide is the parabola? 1 unit. So what do I have to do through the focus? A half on either side. A half on either side. And there's my parabola. Questions? All right, so I have about 8 problems for homework, and you guys have about 25 minutes or so, maybe a little bit less than that.